Hi there, and welcome to IGCSE Maths Tutors. In today's lesson, we're going to learn about graphs and gradients. As you can see here, we have three equations. One is y equals 2x, the second is y equals 2x plus 3, and the third is y equals 2x minus 3. Now, if we want to plot graphs for each of these equations, what we do is that we construct a table just like this one over here, and we select a range for x, let's say from x equals 0 up to x equals 4, and we calculate the value of y for each of these equations for each value of x. So if we start with y equals 2x, for x equals 0, y would be equal to multiplied by 0, which is 0. For x equals 1, y would be equal to 2 times 1, which is 2. For x equals 2, y would be equal to 2 times 2, which is 4. Similarly, for x equals 3, y would be equal to 6. And finally, for x equals to 4, y would be equal to 2 times 4, which is 8. To plot this line, we mark on the graph each of these points, 0 and 0, 1 and 2, 2 and 4, 3 and 6, and finally 4 and 8, and we connect these points together to get the graph of this straight line. Similarly, we start substituting for the values of x to get the corresponding values of y for the equation y equals 2x plus 3. So for x equals to 0, y would be equal to 3. For x equals 1, y would be equal to 2 times 1 plus 3, which is 5. For x equals 2, y would be equal to 7. For x equals to 3, y would be equal to 2 times 3 plus 3, which is 9. And finally, for x equals to 4, y would be equal to 2 times 4 plus 3, which is 11. As we have done with the previous line, we do the same with the equation for y equals 2x plus 3, and we plot these points on the graph and connect them together, and we get this red line over here. Finally, for y equals 2x minus 3, we start calculating the values of y for each value of x, as we have done with the previous two lines, and we get for x equals 0, y equals minus 3, for x equals 1, y is equal to minus 1, and for x equals 2, y would be equal to 1, for x equals 3, y would be equal to 3, and finally for x equals 4, y would be equal to 2 times 4 minus 3, which is equal to 5. And we also plot these points on the graph and connect them together, as you can see over here. We note that all these three lines are parallel, and this is because the coefficient of x, which is the number that is multiplied by x in each of these equations, is the same. As you can see, it is 2 in every one of these equations. We have y equals 2x. In the second equation, it's y equals 2x again, but we add 3. And in the third equation, it's also 2x, but minus 3. And therefore, we can conclude that whenever the coefficient of x for a straight line is the same, these lines are parallel. This coefficient of x is also called the slope or the gradient of the curve or the gradient of the line. And we can calculate it by taking any 2 points on the line and dividing the change in y between these 2 points by the change in x. So for instance, for these 2 points over here, y for the first point was equal to 5, and on the second point y is equal to 1. Therefore the change in y is 5 minus 1, which is equal to 4. Whereas x is equal to 4 for the first point, and it's equal to 2 for the second point. And therefore the change in x is 4 minus 2, which is equal to 2. And thus the change in y divided by the change in x for those 2 points on the line is equal to 4 divided by 2, which is equal to 2. And this is the gradient or the slope, which is also equal to the coefficient of x. So you can either know the gradient or the slope of an equation graphically by calculating the change in y and dividing it by the change in x, as we have done here, or you can conclude it from the equation of the line where the gradient is equal to the coefficient of x. And as we have seen, when the coefficient of x is the same, regardless what the equation of the straight line is, these lines are always parallel. I hope you found this video useful and that you now know how to draw parallel lines and what we mean by the coefficient of x in a straight line, and that this is also the same as the slope or the gradient of the line. If you like this video, please give it a thumbs up. If you still have questions, do leave them in the comments section below. And in the next video, we are going to continue solving an exam question that tackles gradients and parallel lines. So till next time, goodbye for now.